The third section of Unit 9 focuses on similar polygons. And similar polygons basically are two polygons that are considered similar if their corresponding angles are congruent, which means they're the same shape, but their corresponding sides have the same ratio. The symbol we use for similar is basically the top of a congruent symbol. So it doesn't include the equal sign. So what it basically says is similar polygons don't have to be equal. They can be, but they don't have to be. They're the same shape, but not necessarily the same size. So if we have these two polygons, we would read this as ABCDE is similar to FGHIJ. The way the letters are written tells us what corresponds in case we can't tell from the picture. So this question wants us to name the corresponding parts. So on the next slide, I've rewritten the correspondence. And from our definition, we know that the corresponding angles are going to be congruent. So let's see if we can determine what corresponds with each angle. So angle A is first, so it's going to correspond with angle F. And we said our definition says that those two angles are congruent. And then we can continue. Angle B corresponds or matches with angle G, so those are congruent. Angle C is going to be congruent to angle H. Angle D is congruent to angle I. And finally, we know that angle E is congruent to angle J. So as we said, the corresponding angles are congruent, but our definition told us that the corresponding sides are in the same ratio. So we have to match up the sides that go together. So side AB is going to match up with side FG. So we'll say AB to FG is equal to, and now we'll continue setting up the ratios of the other sides. So BC goes with GH, and that would be equal to the ratio of CD to HI, which would be equal to the length of DE to the length of IJ. And finally, finishing up those polygons, we could say side AE compared to side FJ. So as I said, corresponding angles are congruent, so that's why these all have congruent between them, but the sides are in the same ratio. So we set up a proportion saying that each of those fractions is equal. Now the ratio of those corresponding sides is referred to as the scale factor. Excuse me. So if we are looking to find missing sides in our polygons, the first thing we want to do is find the scale factor. So to find the scale factor, you want to find a pair of sides that you have both of the lengths. So the sides that correspond that we know both values would be side AB and side FG. And the way the correspondence is written, it tells us to use the value from ABCDE first, and then compare that to the value from FGHIJ. So we would say 24 to 16 will give us a scale factor of 3 to 2. And you do want to read that similarity statement very carefully because sometimes they switch it around. So the only way you know which shape to use first is based on your statement. So let's use that scale factor to find the other sides. So we know that each pair of sides has to be the same as that scale factor. So 3 to 2 has to equal W to 25. 3 to 2 has to equal X to 15. 3 to 2 has to equal Y to 14. 3 to 2 has to equal Z to 20. Remember, to solve a proportion, we can use our cross product. So I would have 2W equals 75. Dividing both sides by 2 gives me W equals 37.5. I'm going to pause and have you finish solving the last 3 and come back and compare. Remember, when you're setting up your ratios, you need to compare like parts. You need to compare them the same way. Also, some of the problems you may have been able to solve without doing the cross product, but we use that as a backup plan. So hopefully you got those correct. If not, please make a note to ask in class, and we'll continue on the next video.